warming of the Arctic may lose a big part of what's up there. The numbers are all over the place about how much carbon can come out, and it's because we don't have very much knowledge of what will happen to the Arctic when it warms, and a few of us are beginning to work there now. That's not to say there aren't people working there. It's to say that the emphasis is beginning to shift into the Arctic and other places. Now, on the other hand, here's the tropical forest. This is warm and wet. If the CO2 goes up here, the plants will love it. They'll begin to take up carbon dioxide at a great rate. And scientists in Australia have been among the champions of the idea that the tropical systems of the Earth are our savior. Graham Farquhar in particular, who studies isotopes, has said that they see great potential for the tropics to take up carbon. Graham Farquhar is at the Research School for Biological Sciences in Canberra. However, one of the big concerns about the tropical systems is that they may begin to dry out. And if they do and begin to look like this, then this no longer becomes a really big sink for carbon dioxide for us, and that is really worrisome. So you begin to see here how plants play a major role. But I have to tell you, it's much, much more complicated than that. Because plants require a lot of water, and they pump a lot of water into the atmosphere. And one of the things that the Amazon basin does is it keeps the region relatively cool by evaporating so much water. If you begin to slow that down, then you begin to heat up the Amazon. That's one of the big concerns. And it goes on from there. If you cut the trees down, you change the color. In the Arctic, if you allow trees to grow into the north, it changes the color and it causes warming. In the tropics, if you change the color, it may even cause cooling. So it's much more complicated than I'm going to try to explain to you this afternoon. But the take-home lesson is this, that the climate changes that we're inducing are having a major effect on the land plants, and that's going to have a feedback onto the climate system. This is Dr. Derek Emus, who works for the Water Board here in Australia. No swimming or diving. This river or lake or whatever it was has long since disappeared. Out at the University of Western Sydney, they're studying the impact of drought on the eucalypts. They have this huge study going. It got started about 2 years ago, and it immediately started to rain. And unfortunately, this is just the way it happens. They were trying to study drought, and instead they got a deluge. I'm going to tell you briefly about some of the studies that I've been doing on the Chesapeake Bay. This one is the original one. It's been running now for 23 years. Chesapeake Bay sometimes floods. This is what a system you would call well-watered. It's right at sea level. But down in Florida, we have another system on the Kennedy Space Center where we're using lots of high-tech tools to study how these plants will regrow after a burn. This system is fire-dependent, like your vegetation here. And the big take-home lesson that we've gotten from all these studies is that you get a big effect of elevated CO2 on the growth of plants. This is the total growth here caused by elevated CO2. These are the controls over here. That's a 70% stimulation of just the shoots. Extreme climate change would destabilize virtually every aspect of modern life. That's from this publication. It was put out by the Foreign Policy and National Security Implications for Climate Change Center for Strategic and International Studies, quoted in Ross Garneau's study that was released in July. Out at the University of Western Sydney, they're studying the impact of drought on the eucalypts. They have this huge study going. It got started about 2 years ago, and it immediately started to rain. And unfortunately, this is just the way it happens. They were trying to study drought, and instead they got a deluge. I'm going to tell you briefly about some of the studies that I've been doing on the Chesapeake Bay. This one is the original one. It's been running now for 23 years. Chesapeake Bay sometimes floods. This is what a system you would call well-watered. It's right at sea level. But down in Florida, we have another system on the Kennedy Space Center where we're using lots of high-tech tools to study how these plants will regrow after a burn. This system is fire-dependent, like your vegetation here. And the big take-home lesson that we've gotten from all these studies is that you get a big effect of elevated CO2 on the growth of plants. This is the total growth here caused by elevated CO2. These are the controls over here. That's a 70% stimulation of just the shoots. And now this is the annual growth, and you can see that some years absolutely nothing happened. So there's good news and bad news. The good news is the plants take up carbon dioxide as we expected. However, when it's dry, they don't take up any carbon dioxide at all. Nothing happens. Now, just here at the end, I want to try to give you some sense about how much carbon dioxide we're putting up and what you can actually do about it, and what the various approaches that have been proposed in the energy talks that you've heard earlier would do for, say, a family of 4. And I'm going to use a little device here that a graduate student working with me put together for his graduate committee. He knew that they were difficult to convince and that they needed careful leading, and so when you see this, you'll understand how effective it was on his graduate committee. He starts with the idea that you fill up one of these Goodyear blimps with carbon dioxide. Now, you can see that, you can know how much that is. And in America, on average, each of us produces enough CO2 to fill 2 of these, so a family of 4 would fill 8 of them. And he asked the question, if we put all these blimps together, how much of the United States would they cover? I mean, it seems like a ridiculous thing to ask in the first place because it's hard to imagine that we produce that much carbon dioxide. But here's what it turns out, that if you pack all these blimps together so the sun can't come through, they cover all of the southeastern United States on the amount of carbon dioxide that's produced in the United States in 1 year. And for the rest of the world, including Australia, it covers all of the United States east of the Mississippi River, and that was up until 2003. But since 2003, the Chinese have been very busy, and now we produce enough carbon dioxide to add the state of Texas. There's something poetic about this that we need not get into. Let's look at what would happen if we asked to do this exercise in Australia. Well, it turns out that the amount of CO2 we produce in the United States would pretty much cover all of New South Wales and some of Queensland, and then here's what it looks like if we add in all the other blimps. Now we're going to look at this family of 4 and ask the question, suppose this family of 4 decides to reduce its carbon footprint, what are its options and what can it actually accomplish? So we have the 8 blimps, and the color code here is this is transportation. This is energy produced to keep that family going by burning coal, by nuclear power, and so forth. The light color here is household energy, heating our homes, running our refrigerators, and so forth. All right, so the first thing is let's change household energy by replacing our electric water heater with solar, something that you could really do here in New South Wales and is being done more and more in the States, and it is actually affordable. Then you reduce your carbon footprint by 0.4 blimps, 1/16 of your carbon footprint. That doesn't seem like very much. Let's look at transportation. Suppose we all start to drive hybrid cars that get 50 miles per gallon. What would that do? That would reduce the carbon footprint of this family by that much, much more. So it's a really effective way to reduce your carbon footprint, that is to change to a car that gets much higher mileage. Even better would be to drive a bicycle, I suppose, but that's utterly unrealistic. Now let's get to electricity and our folks back at home. If we could capture CO2 and sequester it, if we could switch to nuclear and use wind, solar, and biofuels, we could reduce our carbon footprint by 3.2 blimps.